In this lecture, I would like to discuss on fuzzy logic. A fuzzy logic system is a form of many-valued logic in which the truth value of variables may be any real number between 0 and 1, and both 0 and 1 is inclusive. It is employed to handle the concept of partial truth, where the truth value may range between completely true and completely false. Consider for describing the fuzzy logic system, consider an example where in your consider the example like a set of students, universal set of students in your class, and I have to define a set of students who are tall. So this particular problem is fuzzy in nature. You don't have a specific solution. You cannot include, say, a subset of students all who are tall, or a group of students from among the entire class. I cannot choose them exclusively, because each and everyone, the concept tall is implies to each and everyone in the class. So you have to assign a value between 0 and 1, because when you ask to your friend that are you tall, the person will relatively say that I am this much tall enough, right? Or relative to some measures of in centimeters, right? And consider a person with 5 feet 6 inch. This person would say that I am tall, like I'm almost tall, about 80 percentage or say 75 percentage, right? So this kind of problems are fuzzy in nature, where you cannot assign a true 0 or 1 value to the particular problem, right? So in such kind of solutions, such kind of problems, we assign a truth value which ranges between 0 and 1, and both the 0 and 1 is inclusive enough, right? A person with 4 feet, we cannot consider the person is tall, right? The person is considered as short only, right? So such kind of people can be assigned a truth value of 0, right? So even then, that particular person is a member of that member with a membership value 0. Right. There are several applications related to the fuzzy logic system. Best examples to the examples to the fuzzy logic is air conditioner system and the washing machine. And you know that in air conditioner system, the parameters or the inputs that would be taken in a core room would be the temperature of the room, and also the second parameter or second input parameter would be the humidity of the room. You know that these two factors affects the coolness of the room, right? So you may be setting a set of rules. We can set a set of rules based on these input parameters, right? The first rule can be, if the temperature is too high and if the temperature is high and humidity is high, then cool the room. Your second rule can be, if temperature is high and humidity is low, then cool the room, right? And you can even add the rule, right? If the temperature is low and the humidity is low, then increase the temperature, right? So such fuzzy rules, such rules are used to solve a particular system using fuzzy logic. Another example application is washing machine, right? You know that there are several automatic washing machines which would be using, which uses the fuzzy logic systems to to clean the clothes, right? So there you can consider two inputs, right? The first one would be the dirt of the cloth, and the second one is the kind of dirt inside the on the cloth, right? So this can be two inputs, and based on these two inputs, we can bring about the output, or the output of the unit to be the time for required for washing, right? So based on these input parameters, it has to automatically set the time for washing. And here it may be again, here also we may be setting some set of rules for generating the time for concluding the time for washing, right? And these inputs can be taken with respect to by the availability of some sensors. That is not a matter of concern in our fuzzy logic system. Anyway, inputs are these parameters, right? Before moving on to the fuzzy logic system, let us rewind what is the good old classical set theory which we have learned in our engineering degree, right? A set is defined as a collection of objects which share certain characteristics. A classical set is a collection of distinct objects, right? When we have learned a classical set or no, a set theory, but there we had a set, we represented a set, either the elements would be a member of that particular set or it will not be a member, and each set would be associated with the universal set, like the one we have discussed, that is the your universal set can be the set of students in your class. Number of elements in U is called the cardinal number. Collection of elements within a set are called subsets. So associated with this universal set you can generate several subsets. And classical set is defined as the U is split into two groups. It is members and non-members. No partial membership exists in classical set theory. These are the sample representation for representation of sets in a classical set theory. You can either write it like this: set A is equal to set 2, 4, 6, 8, 9, 8, 10, and or you can define the set as A is equal to X such that X is prime number less than 20. Another, you can even apply formula inside a set, or you can use logical operates, right? Operators. And there exists a membership. Here in set theory, there exists a membership function which may be defined as membership of X of each element in A is equal to 1 or 0. If X belongs to A, you can say that the membership value is 1. If does not belongs to A, if X does not belongs to A, the membership value is 0. Now coming to the fuzzy logic is a form of multi-valued logic to deal with reasoning that is approximate rather than precise. So we are dealing with problems in real life where we don't have a precise solution. So to bring about a solution to such problems, we can use fuzzy logic systems. Fuzzy logic variables may have a truth value that ranges between 0 and 1 and is not constrained to the two truth values of classical proposition logic. As we had discussed, in classical proposition logic we have only two values, it is 1 or 0, but in fuzzy logic system the membership value ranges between 0 and 1. Both the 0 and 1 is inclusive, and if the value is 0, the membership value of an element in fuzzy set is 0, then we'll say that it is absolute falseness, and if 1 represents the absolute truth. And fuzzy set is characterized by the range of values between 0 and 1. So this is the picture diagrammatic representation of fuzzy logic system. That is, it takes in precise and vague data, and the data is processed using fuzzy logic system, and decision is made. We had already discussed the two application related to the fuzzy logic system, right? A fuzzy set here, membership value, consider a fuzzy set called tall. Here you can see this is a membership function for the fuzzy variable tall. You know that people with above 150 centimeters can have less than medium height, right? So you can assign a membership value near to 0, and up to 180 you can assign a membership near to 0.5. We can say that he is 50% tall enough, right? Or relatively, and people above 210 is considered as full, has much height related to the others, right? So this is the height in centimeters is represented using a membership value between 0 and 1. People who are less than 150 have a membership value equal to 0, right? Fuzziness describes the ambiguity of an event, and randomness describes the uncertainty in the occurrence of an event. Fuzzy logic consists of fuzzy inference engine to perform approximate reasoning. Fuzzy set form a building block for fuzzy if-then rules. A fuzzy system is a set of fuzzy rules that converts inputs to output. So this is a fuzzy inference engine which facilitates the solution to a solution to a problem which is defined using, which is solved using fuzzy logic system that performs approximate reasoning. You can see that here it takes in a fuzzy input set, a fuzzy set in X, right? And it takes a set of rules from fuzzy rule base. Using these elements, it generates a corresponding output, right? Now coming to the theory, fuzzy set, right? Coming to the fuzzy set theory, fuzzy sets may be viewed as an extension and generalization to the basic concept of crisp set. It allows partial membership. That is very important. It allows partial membership. A fuzzy set is a set having degree of membership between 1 and 0. Membership of one fuzzy set can also be a member of the of other fuzzy set in the same universe. Vagueness is introduced in fuzzy set by eliminating the sharp boundaries that divide members from non-members in the group, right? So you cannot have a put an exact boundary to the problems, right? This is the definition for a fuzzy set. A fuzzy set A in the universe of discourse U can be defined as a set of ordered pairs, and it is given by A is equal to X comma membership A of X, where X element of universe, right? So a particular element in a fuzzy set can be represented as the element comma the membership value, the element comma the membership value, the person's name comma the height of the person, right? So similarly you will be having n number of elements for the students in the class, right? So this is membership of A of X is the degree. This represents the, this particular notation represents the degree of membership of element X, right? And this value can range between 0 and 1, and this is closed interval. Another representation is when U is discrete and finite. Fuzzy set A is given as. It can also represent like this, right? This is not this symbol, and the plus symbol is not the equivalent symbol in a normal arithmetic algebra. Here this represents this is a membership value corresponding to element x1, and this is a membership value corresponding to member x2, and this represents the collection of elements in the entire fuzzy set, right? Also it can be represented in this form, and n is a finite value. Since it is discrete, the summation symbol indicates the collection of each elements, right? When U is continuous and infinite, this is a case of discrete, right? When U is continuous and infinite, fuzzy set is given as in this form, right? A is equal to integral of membership of A of X by X. The integral sign is a continuous function, theoretic union for. Here the theoretic union for continuous variable, right? A fuzzy set is universal fuzzy set if and only if the value of membership function is 1 for all members, right? ഇപ്പോൾ ഒരു particular സെറ്റിനെ fuzzy set എന്ന് പറയാനാണെങ്കിൽ the membership value of that of the elements in this in the set would be equal to 1. The universal fuzzy set can also be called as whole fuzzy set. Two fuzzy sets A and B are equal if membership of A of X is equal to membership of B of X. So you can relate. I mean, you can say the two fuzzy sets are all equal only if and only if the membership value of each element in both A and B should be equal, right? For example, the membership value of x1 should be in A should be equal to the membership value of x1 in B, right? So that corresponds to every element in A and B. A fuzzy set A is an empty fuzzy set if and only if value of membership function is 0. So all those elements, the membership value is, if it is equal to 0 in a fuzzy set, we will say that it is a empty fuzzy set. Now coming to the fuzzy operations, yeah, similar to classical set operations, fuzzy set operations exist, right? You have you had the union, union, intersection, complement, etc. Similar to that, we have same set of operations, but the operations differs with respect to the classical set theorem, right? So this is how we represent a union operation, A union B. So membership value, its corresponding membership value is equal to maximum of membership value of A of x, comma, membership value of B of x. So considering an element say x, you have to take whichever is the maximum value. If it is in A, then you have to consider that membership value. If it is in B, then you have to consider. We'll do problems related to this, so then you will understand, right? This is the operator corresponding to the max. And A intersection B, that is membership value of A intersection B, is you have to apply the minimum operation. You have to take minimum among the fuzzy sets A and B. This is a graphical representation. Complement is equal to A complement, membership value of, fuzzy set A complement is equal to 1 minus a membership value of A of x for all x element of U, right? So you have to subtract it from the membership value of each element from 1. Algebraic sum is represented as this: A plus B is equal to membership value of A of x plus membership value of B of x minus membership value, product of these two, right? Algebraic product is equal to, you have to multiply the corresponding membership value of each element, right? So you have the bounded sum is expressions for bounded sum and bounded differences given here. These are the properties of fuzzy sets. It satisfies the commutative property, associative property. You have to consider 3 fuzzy sets in associative to prove associativity. That is A union braces B union C is equal to any A union B union C, and similarly for intersection also. Your distributivity is also true for fuzzy set, and idempotency, transitivity, and identity. And the next set of properties are involution, and it satisfies the De Morgan's law. The first problem is related to the power set. Classical set theory. You are asked to find the power set and cardinality of the given set. You are given x is equal to 2, 4, 6. You have to find represents the power set and cardinality. Also find the cardinality of power set, right? Right. So set X contains 3 elements. The solution is set X contains 3 elements, 2, 4, 6. So we have the cardinality of set X is equal to 3. Now you can write power set as all the subset including the phi and the entire set, right? So phi, 2, 4, 6, all these are this entire set represents the power set. The cardinality of power set P of X is given as 2 raised to the cardinality of x. So 2 raised to the cardinality of power set is 2 raised to 3 or equal to 8. Even if you count 1, 2, 3, 4, 5, 6, 7, 8, right? So mathematically it is given power set, cardinality of a power set is equal to 2 raised to cardinality of x. That is equal to 2 raised to 3 equal to 8. Now this is a problem we related to the fuzzy set, right? You are given two fuzzy sets. You are asked to find union, intersection, complement, and difference, right? A is equal to the fuzzy set. A is here. You can see in A, how many elements are there? Four elements are there, and its corresponding membership value is given. The elements are 2, 4, 6, 8, right? B, you can see can have same number of elements 2, 4, 6, 8, and its corresponding membership value is also given, right? So you are asked to find the union, intersection, complement, and difference operator. The question is here, that is two sets are defined given here. For taking up the union A, to perform A union B operation, what you have to do is that consider the element 2 and look into the membership value of 2 in A and membership value of 2 in B. Here in A, the membership value of 2 is 1, and for B, the membership value of 2 is 0.5. So you have to take maximum of out of these values. So maximum is 1. So you write 1 by 2. Alright, so don't get confused with this plus and this division operator. This is not exactly the division and the arithmetic sum here. It just shows this line shows the two, I mean, one is the membership value of element 2, and this plus signifies the number of elements, the entire constitute the entire elements in the set, fuzzy set A, right? So you have to consider for element 4 the membership value of value in A, it is 0.3, and in B it is 0.4, and hence this is union operation. You have to consider the maximum value. So the maximum value is 0.4, and so A union B, the membership value of 4, here it is 0.4, right? And for 6, element 6, out of these two values it is 0.5, maximum is 0.5, you can take 0.5. Similarly for element 8, right? Intersection, instead of considering the maximum, here you have to consider intersection definition is you have to apply the minimum operation, right? So for corresponding to each element you have to take the minimum, right? So 1 and 0.5, 0.5 is the minimum. So when you apply A intersection B, the membership value of 2 would become 0.5, and for element 4, 0.4 and 0.3 are the membership value with respect to B and A. So out of these values, minimum is 0.3. So we write 0.3 by 4. And similarly for element 6 and element 8. This will give you the result for after applying A intersection B. Right. Now complement. Complement is also very simple. You can see A complement is nothing but is defined as 1 minus membership of A of X. So what you have to do is that you have to consider each element and you have to subtract membership value corresponding to this.